Hey guys, this is John Starrett here, and today we're going to give you another tip focusing on scalar functions versus table functions. Now, when I started working as a developer, I really loved scalar functions because I was an object-oriented programmer and I loved to reuse code. Back then, I didn't understand how the optimizer interpreted scalar functions and actually ran them as row-by-row processing instead of set-based logic. And today we're going to show you how this is one of those areas of architecture that I would call as a silent performance killer. And the reason why is even when we use some of the techniques that we would normally have in our benchmarking toolkit, like looking at our set statistics for I/O and time and execution plans, you're natively not going to see the row by row processing here. So let's get started with this. We're going to go ahead and we're going to use our InventionWorks database here. We're going to have our set statistics on. All right, and then we are going to use two functions. The first one's a scalar function here, and this one we're going to call get max product quantity scalar. And all we're doing here is we're passing in a product ID, and we're using this product ID because we want to figure out the max quantity of orders there that have been processed there with that product ID, and then we're going to go ahead and return that. So we're going to get started here, and we're going to get started by having our same consistent starting point by actually starting with nothing in memory. So we're going to run a checkpoint so we take all dirty pages here and persist them out there to disk so then we can drop all of them as clean buffers here. And then we're going to throw out our execution plans. Once again, you don't want to do this in production. We're doing this here so we have the same exact starting point here as we're benchmarking in a non-production environment. All right, so now we're going to go ahead and run that scalar function here, right? Get max product quantity scalar here. So for every row here, because we have no filter in our products table, we're going to go ahead and we're going to see that we're actually calling this function here, which references the sales in large order table here. And we're going to return the product ID with its quantity here. So let's go ahead and let this guy run. And we're going to see that this is going to run for quite a few seconds over here. All right, so we're going to fast forward a little bit here because you can see that this took 23 seconds to complete. So we have 504 rows returned. Let's go ahead and look at our set statistics here. So if we just look at I/O, we're going to think, whoa, this is great, right? We got 4 logical reads, just 4 logical reads here. There's not a whole lot we're going to do to tune this here. But keep in mind here, this is just the product table. This is why I mentioned scalar functions can be known as a silent performance killer, because we're not even going to see this in here. Remember, if we go back and we look here, that our function is actually going across the sales order detail enlarged table, and we don't even see this anywhere in here. Right? All we see is a work table and our product table. Let's go look at the execution plan. Same thing here, right? All we see is an index scan across our product table, and there's no mention at all about the sales order detailed enlarged table at all in here. So when we go look at this, and we actually look at our CPU here and our total duration time here, this is pretty confusing, right? Because we have a lot of time that we don't see in here. So one of the things that we can do here is we can set up an extended event or a server-side trace, which I had running here. And this is where we're going to actually see our row-by-row processing here. So if I go ahead and expand this out, we are going to see for every single row we had in there, we're calling that function, we're doing the select statement, and we're returning the value over and over for every single row. And this is what really slowed us down there that caused the 22 seconds for this query to run. All right, so now that we understand why scalar functions aren't good because we can see row by row processing, what can we do to fix this design pattern and how can we make our own code better? All right, so once again, we're going to start with that same starting point by having nothing in memory here. So we're going to go ahead and run our checkpoint, our drop clean buffers, and our free proc cache. So once again, this is going to take any data pages that would have changed. It's going to put them in the data files here so they're clean, and then we're going to clean all of our, or drop all of our clean buffers, and then take all of our execution plans and throw them away. So now we're going to go ahead and go through here, and we're going to go through running our table function. So the difference here, we're still taking our product ID in, but this is going to be an inline table function because we're actually going to get it in, and as a set here, we're going to pass those values in, and we're going to go get the max for those product IDs in here. So we're going to go ahead, as I mentioned here, get our starting point here by removing everything out of memory. So we start from that same spot of nothing in memory. So we have a apples to apples comparison. And now we're going to go ahead and run this query here, where we're actually going to do what's known as a cross apply. So we're going to take our product IDs as a set into the function and get our results back out here. So let's go ahead and run this. And remember, we took 22 seconds for this to run, and we can see here in about 2 seconds we're done. So just from time alone, we're seeing about a factor of 10 improvement here. And we didn't do any indexing or anything other than making your scalar function become a table function here. So let's go look and see what's different. So the first thing that should jump out here is our sales order detail enlarged table is here. It's no longer silent, mean not shown. It's now exposed and it's part of our query in here. And we can see while it still has about 50,000 logical reads and could be improved here, we've already improved this query by a factor of 10. And we can see that by looking at our time here. So you can see that we went from 22 seconds to about 2.5 seconds. The other thing to notice is our execution plan here is changed, and it now includes everything in there. So we can see that we're actually scanning here to get our data here. So we still may have some opportunity for improvement. But the main point here is we have our silent killer, our actually big sales order detailed enlarged table, is included in the table function where it wasn't in the scalar function. We also had row by row processing, where now when we go back over here, we can see that we don't have that here. We just have our single select statement here, and that shows our total time here. Instead of before, we had our row by row processing where we called the scalar function for every row that went inside of it. So once again, to recap, when you ski a scalar function, keep in mind that you're going to do row by row processing across it. And if you're able to push that over into a table function, that will allow you to use set-based logic and allow you to process a set of data at a time instead of do row by row processing, which should give you much faster execution times. So once again, this is John Sterrett. I hope you enjoyed this tip and look forward to seeing you watch some of our other tips in the future. Thanks.